Good morning. Today we're going to learn how to draw orbital diagrams and electron configurations, both full configurations and noble gas ones. In order to do this, you're going to need a periodic table, and you need to be able to calculate how many electrons are in a neutral atom of that element, as well as how many electrons are in an ion of that element. Let's go ahead and get started with hydrogen. You should know by now that hydrogen has one electron. So when we do the electron configuration for hydrogen, we're going to start with 1s, because that's the energy level or the shell that electrons always fill first. You know that 1s is the one they fill first because we always start with the first period, and the first period corresponds with the first energy level. Hydrogen has one electron. I'm going to draw a little flag or an arrow to represent that one electron, and my orbital diagram for hydrogen is finished. When I write my electron configuration, I would write 1s1 for hydrogen, and that's it. I'm done. Let's do helium. Helium has 2 electrons. So when I'm doing my orbital diagram, I would draw 2 flags or 2 arrows for my 2 electrons, and again, I'm finished. These 2 are pretty easy. So when I write my electron configuration for helium, I would write 1s2. 1s is my energy level that you see over here, and 2 represents the number of electrons that are in that energy level. Hydrogen has 1, helium has 2. Let's do lithium. Lithium has 3 electrons. So when I'm doing the orbital diagram for lithium, I'm going to draw my 2 electrons in 1s, but 1s is now full. I can't put anything else there. So I have to drop down to the 2s energy level, and I'm going to draw my 1 electron. So when I write the energy configuration for lithium, I will write 1s2, 2s1. The 2s is the energy level, and the 1 is the number of electrons in it. Let's move ahead. Let's do something like carbon. Carbon has 6 electrons. So when I do the orbital diagram for carbon, I'm going to fill in 1s. I'm going to come down to 2s. That gets full with 2 electrons. And now I have to move over here to 2p. Electrons are a lot like people at a bus stop. They don't like to share benches. If there's an empty bench, the electrons will usually fill that. And then once all the benches have somebody, the next person or the next electron will choose to share. So this is the orbital diagram for carbon. And if I write down the electron configuration for carbon, I write 1s2, 2s2, 2p1. Let's drop down into the 3rd period, and let's pick something like aluminum. Aluminum has 13 electrons. So let's do the orbital diagram for aluminum. 1s, we fill it with 2 electrons. 2s, we fill it with 2 electrons. 2p, we fill that with 6 electrons, because the p orbitals can hold 6 electrons. I come down here to 3s, I fill that up, and then I have 1 left over to go into my 3p orbital. Let's write out our electron configuration. 1s2, 2s2, 2p6, 3s2, 3p1. We're only on the 13th element, and this is already getting kind of long. So there's a shortcut we can do. We can do something called the noble gas configuration. First of all, you have to find the noble gas that happens before the element we're talking about. We're talking about aluminum, element number 13. The noble gas that comes before that is neon. Neon is number 10. Neon has 10 electrons. If I do the orbital diagram for neon, you're going to see that the 2nd period, the 2nd shell, is completely full. You should know that. Neon's a noble gas. So when I write the orbital or the electron configuration for neon, I write 1s2, 2s2, 2p6. Well, you see that corresponds with this section of aluminum. So when I write aluminum, instead of writing 1s2, 2s2, 2p6, I can take a shortcut and just write neon. And now I just have to write the things that came after that. So I write 3s2, 3p1. And that's how I do the noble gas configuration of aluminum. Let's do just a few more. Let's do chlorine and maybe we'll stop there. Chlorine has 17 electrons. We know that chlorine is a halogen. It has 7 valence electrons. It's only missing 1. That's pretty long. I'm going to do the noble gas configuration. I'm going to write Ne and then 3s2, 3p5. We know chlorine's a halogen. We know it has 7 valence electrons. We know that chlorine really wants to steal 1 more. So we can do an orbital diagram and an electron configuration for the chlorine ion. It has stolen 1 more electron. So we're going to fill that in. Now, I could write out the full configuration, or I could do the noble gas configuration. Let's do the full first. 1s2, 2s2, 2p6, 3s2, 3p6. You'll notice that we have a 3p6 instead of a 3p5 because chlorine stole an extra electron. Or I can do the noble gas configuration. Chlorine stole that 1 extra electron, so it has 18 electrons. Well, the noble gas closest to that is argon. That has 18 electrons. So the noble gas configuration of the chlorine ion would just be argon. That's why chlorine stole that extra electron, so it can look like one of the noble gases. I am going to do one more. You may have noticed that things made sense at these levels, but when we get to the 4th period, we have 4s2, and then there's a 3d shoved in there in between the 4s and the 4p. I don't know why they do this, but they do. That really is a d level on the 3rd energy level, but it's slid underneath the 4s. So when we're doing orbital diagrams and electron configurations for the elements in periods 4, 5, 6, and 7, it can get a little confusing. I don't expect you to memorize these. I give you charts. I expect you to use those charts. So let's do something like gallium. Gallium is number 31, so it has 31 electrons. We're going to start filling in. Our 1s fills in, 2s, 2p, 3s, 3p, 4s, and then we have to put this 3d. Use the charts I give you to help you remember and figure out which shells and orbitals come next. Now gallium has 1 last electron and it fills in that 4p. So the electron configuration for gallium, the full electron configuration, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, I'm going to write these down here, 4s2, 3d10, 4p1. Or the noble gas configuration would be argon, and then just this bit down here, 4s2, 3d10, 4p1. Argon encompasses this whole piece up here, so we don't have to rewrite it. I hope that helps you to figure out electron configurations and orbital diagrams.